Welcome, everyone. So, let's see here. Before we get started, what's happening? Oh yeah, homework's not done yet. I will have those graded this week, I promise. But yeah, so I don't have those finished yet. I think what the calendar is all about here. So, right. So this week we will go over statistical thermodynamics. Next week we'll just kind of review everything we've done since exam 2, and then we'll have Thanksgiving break, and then after break we'll have 2 exams and another review.
So our exam was on a Wednesday, the 9th or something. I thought it was like a week after we get back.
Yeah,
Monday and Friday.
so the week right after Thanksgiving break is still like as regular classes meeting until Thursday or Friday of that week, and then the following week is the middle of like finals week. And maybe finals might start that Friday. I forget, Friday or Saturday.
Friday's like an off day. It's like reading day.
Yeah, I know. Like there's reading day. I guess that's probably Friday as well. But yeah. So anyway, so finals won't begin until kind of the week of December 7th. Basically, I don't know. There are some time slots I think get put on the weekend. I don't know. It's kind of never had anything like that. But anyways, so ours is Wednesday, December 9th at a bright and early 8 a.m. So just keep that in mind. The final is not going to take the entire like 2.5 hour window or whatever that's planned. Right? I mean, typically, if I gave the ACS final, which I'm not going to because I can't give it online, right, the ACS final is like I think like 100 minutes or something like that. So I don't know exactly what the time length of the final exam I'm going to write will be, but it's definitely not going to be designed to try to take up the entire time. But I mean, do expect it to be a little bit longer than any regular exam, just because it's got to cover more material, right? The final, assuming I have it written down correctly and I looked it up properly and I wrote the syllabus, should be December 9th at 8 a.m. So, but the Monday after Thanksgiving break, there's a regular exam. Well, exam 3, and then the next week is the final.
But we have class on that Wednesday.
Yeah, to review for the final. Yeah, so. Right. pull up the thing here, right? So the schedule and the syllabus, right? Right, so we're this week here, November 16th, right? And next week's Thanksgiving break. We'll do a review for the third exam at Monday. And then following week after Thanksgiving, we'll have an exam. We'll review right that Friday, so like a reading day. Classes do not meet. And then the week after that is the final exam on Wednesday.
Oh, okay, you don't mean on this. Okay.
Yeah. Okay. And clear up timeline, everything. Anyone else have questions?
So is this the last like material we're covering for the class?
Yeah, this week.
Or is this lecture the last
Um,
material we're learning?
No.
Sit. Huh?
Yeah, so this last lecture, but no, we saw Wednesday. and
Yeah,
Friday.
no. I still have things planned for Wednesday and Friday. So no, we'll meet every day this week. We'll see. Like I have certain things planned for those days. I don't know exactly how long each thing will take. So it might not be like a full class time each day this week, but there are different things planned for each day this week. So yeah, we will continue to meet throughout this week.
Yeah, for sure. Just,
Oh yeah, and homework 6, right?
Next Monday.
Yeah. Yeah, it's a shorter homework. Right. Yeah, so homework 6 is due a week from today, due before Thanksgiving break. So then, yeah. So all that's left after Thanksgiving break is to take 2 tests, basically. Woohoo! All right. So I don't know.
You do have question form on the quiz.
Okay. So yeah, there's a question about doing question 4 on the quiz. Any other kind of questions?
Have you graded class homework?
No, I was saying that earlier that I'm not finished, but I will get it graded this week. It will be, I promise. We'll get it back soon. But yeah, I haven't gotten that graded quite yet. I kind of answer. I didn't fully hear the question from on Zoom. Did I kind of answer your question, or are there any other questions?
I figured we were still going to go to class like the rest of the week. I was just making sure if this was the last new material that we were learning on today.
Yeah. So this week there's lectures 31, 32, and 33. There's PDFs and some videos related with those are posted online on Canvas and YouTube. And so we'll do those the 3 days this week. Yeah. All right. So there's a question about the Canvas participation quiz. Why not? So just give me 1 second while I pull up the question. One for 2-step verification, blah, 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 blah. And I miss my old iPhone with the finger scanner during all this crap. Having the face scanner thing comes up and I gotta wait for it to decide it can't scan my face with the mask on.
I think you're trying to do it with the mask on. Like, they're trying to allow it with the mask on.
I don't know.
I think it's just a limited role.
Yeah, I don't know. Yeah. No. But anyways, I digress. But yeah, so let's see here.
That's better than mine, but
Yeah.
it's SE, so it's basically an 11.
Quizzes. Which was this? Actually, let me go back to the syllabus. Just get there. Equilibrium and electrochemistry. Review. All right. Okay, so I'm gonna freeze this. Let me go to Zoom real quick. Let's share the event. Okay. I believe I'm sharing this for Zoom. Yeah, yeah. I guess I forgot the not on there. Yeah. I forgot to specify that. I mean, I am trying to think if there's ever an example of problem where you're given like just a reduction potential or oxidation potential for a half reaction and it's not the standard. I know you don't know that, and so it's a very valid question. But just I guess for future reference, uh, if you're ever under non-standard conditions, it's typically going to be presented in terms of the overall cell potential for the overall chemical reaction, and not for a given half reaction. I'm not sure. Because right, you can't really measure the cell potential of a half reaction under non-standard conditions. You only measure the cell potential of the total reaction under non-standard conditions. Right. Um, so yeah, so that's why those kind of reduction potentials and things like that are all typically kind of standard values. So yeah, so I apologize not making that more clear here, but for future reference, if you ever see a reduction or oxidation potential, you can assume it's at standard conditions if it doesn't specify. So is that just a question, or do you want to go over the go through? Okay. All right. Right. So what we're asked, what is the cell potential for a galvanic cell at 298 Kelvin, given those concentrations? Okay. So given those two half reactions, right, if I want a galvanic cell, that means that a spontaneous reaction means the overall cell potential has to be positive, right? So which of these two reactions do I have to flip to an oxidation reaction to make this an overall positive? Right, the top one, right? To flip the top one, so I have a positive 1.71 minus 0.76. And I know you guys can't see what I'm writing down right now. And then right, we know that the aluminum concentration is equal to 0.1230. And the zinc one is 0.063 molar. Okay. And with this cell potential, right, the reaction that we have then is aluminum solid. I'm going to balance it real quick. Plus zinc ions going solid zinc plus aluminum ions. Okay. So let me actually this one. Oh yeah, that's right. Forgot this thing's like a touch. Ah, with that. Oh, what? No. I'm so excited. There we go. Didn't even use the mouse. All right. Right. So this is kind of information, right? This is our balanced electrochemical reaction that we have. Okay. This is the cell potential, right? With like 0.95 or 0.9? No, that's not right. Oh, it is 0.95. All right. Should have stuck with my original hunch. Right. 0.95 volts. All right. Is the standard cell potential for this reaction. Okay. And again, this is the balanced chemical reaction where a total of 6 electrons is transferred from one side, from aluminum to zinc, right? Notice here that we have aluminum 3+, not gold 3+. Learned my lesson. Right, and so for this, it's just using that Nernst equation. So the cell potential is E cell naught minus RT over VF ln of Q, right? Or we shall not minus 0.05591 roughly v log q. And if I remember that correctly. And so the cell potential itself, right, just plugging in 0.95 minus 0.0591 divided by 6 times the log. And then Q here is going to be concentration of aluminum ions squared divided by the concentration of zinc ions cubed, which that sucks. Because I gave you the wrong answer, son of a gun. See, working this out, like I even can remember when I did the problem where I made the mistake without even checking to see I got the wrong thing. Yep, exactly. So, right, so it should be, what is this? 0.00015 squared over 0.063 cubed, right?
It should be 0.99.
All right, let's see here. I should have done that later. Squared. All right, and then take the log of that. On 0.0591 divided by 6. Okay, and then it's negative, so positive plus 0.95. So if I did my math correctly on my calculator, this should be 0.99 basically volts. Okay. Which I'm going to assume is not. Hopefully it was still in the range. My mistake. Nope. Dang it. Darn it. If only I could be so lucky. All right. All right. Okay. All right. Man. Whatever. Anything I am consistent. So. All right. So question about that problem. Right. Okay. Yeah. So I will regrade those after class. Any other kind of questions before we get going about anything? I think what I'll do, it is so I've done this like every year basically for that last week's classes, whether or not the exams were on Monday or Wednesday. And so, and yeah, to be kind of fair with people who are taking the class and have made schedules and travel plans, blah, 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 blah. I think what I'll do is I'll just make a quiz on Canvas that will just be like a survey of whether or not people would like to, that last week of class, have the other review on Wednesday or on Monday and then do the exam on Wednesday, or exam on Monday and then the review on Wednesday, right? So yeah, I'll post that as well. I'll post just, I don't know, if people have a big preference as to whether or not they want to get the exam over with on Monday, or they want a couple extra days. I'll let you guys pick it out. So I'll do that. I will say though, that in order to swap the exam from one day to another, it's like going to require a large majority. It's not just like a 50% or 51% majority or something like that. It's going to be a large majority, just because moving exam days, I try not to do unless basically everyone in class is on board with it. Because again, I put the exam dates in the syllabus at the beginning of the semester so people know, okay, I can prepare to make sure I'm in town and available for this date, right? Maybe someone's like, well, screw it. Wednesday, I don't care about being for the review, and they plan to do something else on Wednesday, and and I don't want to swap the exam and kind of screw them up like that. So it will, yeah, if there are issues like that, then like probably what I'll do with the survey is I'll ask your preference, and then I'll have a question saying like, if you do not want the exam moved, what is your reason, or something like that. So I get some people saying I won't be able to take the exam on Wednesday, and it's just not going to be okay. But we just do a review. Yeah, we just huh?
Monday will be a review.
Yeah, I mean, so we have 2 review days. I guess if we swap the day of the exam, I could like review for the final before Thanksgiving and then review for that exam right before that. But basically, I mean, we just have 2 days for me to just go over whatever questions and concepts and things like topics people want to. So, yeah, I don't know. I'll see what I kind of do with the survey in terms of maybe I'll add a 3rd question about flipping which review we do which day or something like that. So. But yeah, but yeah. So again, I'll just kind of get those options. We'll kind of see what class feels, and I'm more than willing to go with it. So, other questions? Yep. So yeah, my plan on putting some type of study guide for the final. Exactly. Watch every video again. Watch all Zoom lectures. Do all examples. Yeah, I was gonna say my very first suggestion for studying for the final will be looking over the 3 exams. Right, I've posted solutions to those exams, and I'll post solutions to exam 3 as well after we take it. And that's always kind of the best place, because the final, because this year, right, normally I'd say review the ACS study guide for the ACS final, right? But since we aren't taking the ACS final, it's not a bad place to go if you have that ACS study guide for, for PChem. It's not a bad place to go because it has good questions, good kind of concept reviews and things like that. So it's a nice place to look. But if you want to look at questions that are most going to resemble questions on the final 3 regular exams, that I've written, will most represent the final exam that I will write. But that's my first place of starting. But yeah, in terms of the study guide, and maybe I'll put an announcement of topics or things like that. But I mean, technically everything in the class, right? I don't know.
Well, I know it's just gonna narrow down a little bit. Will we have exam 3 back by then? Probably not, right?
Well, if you take it on Monday, there's a good chance I could get it graded and back on Wednesday if I make that a priority. Yeah, so that people can have that available to them. So but yeah, so yeah. But yeah, assuming we take it on Monday, I would make it a priority to get it graded for Wednesday for people back. So Any other kind of questions about things? Yeah, but yeah, in terms of the study guide, I guess, it's tough to say in terms of topics, but yeah, things to review would be first exams, then kind of homework or example questions in class, things like that. But again, there's, but I do understand that's a lot of examples to go over, right? But in terms of that, then my suggestion is to say, what the, hopefully there's some things you feel more confident than others, so maybe focus on the things you're not as confident about. Again, hopefully it's not the entire class, but yeah. So I'll think about that. I'll think about something. So yeah. All right. Okay, so today we're gonna start discussing statistical thermodynamics. Again, as I've alluded to in other kind of lectures, and then if you watch lecture videos online, right, that statistical thermodynamics is sort of the bridge between quantum mechanics and thermodynamics. That using basically the energy levels and things like that predicted and discovered in quantum mechanics, one can use essentially just statistics to derive all of thermodynamics. Okay, so all of thermodynamics, any quantity in thermodynamics can be derived and related through statistics to quantum mechanics and things like that, right? And that should make some sense, right? Because all of our thermodynamic quantities, all our macroscopic things that we observe, right, are fundamentally due to whatever's happening microscopically, right, at the quantum level, at the atomistic molecular level in your system, right? It's just the macroscopic view is this thermally average value of what's happening microscopically and things like that, right? So statistical thermodynamics is just analyzing and understanding those statistics, if you will, right? Those averages and such of your microscopic quantities to predict and determine your macroscopic thing. Okay, right? So, right. And yeah, I kind of wish it was a larger topic. I always felt like this is kind of a super cool thing myself, in terms of physical chemistry, just physical thermodynamics, how you can again get anything from thermodynamics from just analyzing energy levels and things like that, quantum mechanics. So we'll get to that and kind of see where these connections come from and how we get from one to the other. Okay. But before we do that, we just need to kind of remind ourselves of some just basic statistics. Okay. And I believe we kind of talked about this at the beginning of the semester, but we're going to just kind of go over it again here. And if we didn't, then great. But right, and just first talking about probability. Okay. Because that's again a lot of what statistical thermodynamics is talking about probability, averages, and weights and things of that nature, right? Because right, again, when you're measuring, say, the enthalpy of your reaction, right? You're measuring like what is the average enthalpy change from reactants to products and things of that nature, right? And in the individual enthalpy change of each individual molecular reaction that is occurring, right, is going to be a little different from each other, right? They're all going to be slightly different, okay? So they're going to have some type of statistical average. That's what we get out in the lab, right? That's why you always have, in any measurement that you do have some kind of error, if you will, right? Some kind of region of like, this is the enthalpy of my reaction to within, 0.5 kcals per mole, right? One has to do with like, the accuracy of your measurement, but the other is just there are some fundamental distribution of things, right? You know, when we talk about spectroscopy and things like that, and quantum mechanics next semester, right? The absorption or emission spectra of a molecule, if it was perfectly still normal and all molecules are completely identical and not vibrating, not moving, not doing anything, each absorption emission spectra would be just a bunch of straight lines, like you do see for atomistic spectra, right? The spectra for atoms are just straight vertical lines for absorption and emission. Okay, that's how they analyze what the heck's in like stars and planets and things like that across the universe, is by measuring, observing those spectra and determining what those vertical lines represent. Right. But for actual molecules and things like that, where things are vibrating and moving around and rotating, blah, 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 all this random distorted motion causes the absorption energy of your molecule to fluctuate and to have some sort of broadening. It's called thermal broadening of the peaks, right? And so you get, not a single peak, but some broad potential peak, right, that you observe, and that, is, and you can then, like, if you want to take the average of all that absorption, take the maximum value, the most probable value, right, things like that, to determine and say this is the absorption energy of my molecule, right, with some distribution around that. Okay. Right. So, so if we want to find, say, the probability of something occurring, right, we can think of it as the number of ways that that thing I want to occur happens, right? So the number of ways that it can happen, the thing I want, over the total number of possibilities that can occur, right? So right, the probability of something happening is the chance it happens divided by chance anything happens, right? So again, an example of flipping a coin 4 times, right? If I want the probability I get heads twice, I can work it out, right? Specifically, think of the fact that there's 6 different ways, right? I can flip a coin 4 times to get 2 heads, right? And only 2 heads, right? Not at least, but only 2 heads. Okay. Right? There's 6 different ways of doing that. And then when I'm right, and then for the total number of ways, right? Each coin flip has 2 outcomes, and each coin flip is independent of the previous coin flip. So the total number of outcomes is just 2 to the 4. Okay, so 16 total different outcomes. Okay. So again, I have 2 outcomes for the first one times 2 outcomes for the second event times 2 outcomes for the third event. Each event is independent of the other. Okay, so it's just 2 to the 4th, which is 16 total outcomes. And again, 6 ways I can get what I want. So it's a total of 6 divided by 16 is the probability of getting heads twice, right? When you're flipping it 4 times, right? And then this formula here, 4 choose 2, this is a combinatorial notation of things, okay? Right? I have 4 different bins, if you will, and I want 2 of those bins to specifically be a certain thing, heads in this case, right? And so this notation here, 4 choose 2, is I have 4 bins, I'm choosing 2 of them to be a certain quantity, and then the number of ways that that can occur in those bins is given by this formula here, where it's your total number of bins factorial divided by the total number of things you want to happen factorial times the total number of bins minus the total number of things you want to happen factorial. So in this case, it's 4 factorial over 2 times 2 factorial, which 2 factorial, well, like, n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to 1, right? And so 4 factorial is 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. So you get 24 over 2 times 2, which is 4. But this is a very common combinatorics problem, where you have so many bins and you want to choose a certain number of things to happen in those. So questions about this so far? right? So if we expand our coin flipping to 10 coin flips, right? And I can ask myself, what is the probability of getting heads 5 times now? Right? I want to get heads 5 times out of 10 coin flips. Again, I have this 10 choose 5 possible ways of that occurring, which again is based off of this formula of 10 factorial or 5 factorial times 5 factorial, which gives you 252 different ways that when I flip a coin 10 times, I can get 5 heads, right? And only 5, not more, not less, 5 exactly, right? And then again, the total number of different outcomes that can occur is 2 to the 10th, right? 2 to the number of coin flips. So that's 1,024, right? So the probability of getting half of my coin flips being a heads is 25% when I flip a coin 10 times, right? Questions about this?
I was wondering if this is corresponding to a chapter in the book, like if there was a way we could read up on this.
Yeah, there is. So I was just looking at it actually this morning. I don't know if they talk about the coin flips. You don't need to know about like this combinatorial stuff like 5, 2, 10, and blah 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 blah. But they might. I forget if they do this kind of example in the book or not. But there is a chapter in the book on statistical thermodynamics. I can't remember off the top of my head what that chapter number was. Again, I was just looking at it this morning. It's one of the later chapters. It's after the chapters on quantum mechanics. I want to say it's like chapter 12 or 13 or something like that. But there is, in the book, there is a chapter on this. So it starts off, the very first, like 12A or 15A or whatever the first section is of that chapter is on Boltzmann statistics, which we'll talk more about Boltzmann statistics on Wednesday. Today, I just want to kind of review just general statistics and such. And then Wednesday, we'll talk about Boltzmann. Other questions? Right. And so what happened to the probability of getting half of my coin flips to be heads as I increase the number of coin flips? It decreased, it went down, right? I went from 4 coin flips at a probability of getting half of those coin flips being heads at 38%. At 10 coin flips, that reduced down to 25%, right? And that will keep on occurring as I increase the number of coin flips, right? Right, the probability is going to go down, okay? Right, this percentage of getting, so for example, that probability, if you were to work it out for n being the number of coin flips, again, you don't have to memorize this or use this at all, but just, if you're curious, right, that to get half of your coin flips to be heads, that probability is given here. I think in this formula, I assume an even number of coin flips. Yeah, I assumed an even number of coin flips, but assuming you have an even number of coin flips, okay, this is what that probability comes out to be, okay. And this thing itself goes to 0 as n goes to infinity. Okay. So as n gets larger and larger and larger, the probability goes to 0. And this is true in general, that any specific outcome, say, of this flipping of a coin, probability of that one specific outcome happening does go to 0, right? That if you flip a coin, 1,000 times, the chance that you're going to get one specific outcome out of all those coin flips, right, is very, very, very small, okay. Right? But just because something is very unlikely to occur, a specific outcome, okay, doesn't mean we can't talk about and gain information about which of the outcomes are more likely to occur than others, right? Anything about in class, right? Just because, potentially in some class, right, your score on an exam was very, very low, as long as your score was better than the average person next to you, right, you feel pretty good with it. Or at least I did, right? Whenever I took an exam in a class, even if my score looked like crap, as long as everyone else's scores were as bad as mine or worse, I felt fine, right? And so that's, the same thing kind of probability, right? That even if the probability of a specific event is very low, we still can gain some information and learn some things by understanding what is the relative probability of something occurring compared to other things, right? Um, and so, right, and that's the difference between asking for what is the probability of a specific event versus asking something like what is the most probable outcome, the most likely outcome, right? So again, if I ask for 1,000 coin flips, the most likely outcome, right? What would you guess, right? If you had this question, you had to guess what's the most likely outcome if you flip the coin 1,000 times. Of the total set of 1,000 coin flips, what's the, 2 heads and 998 tails, or what? Yeah, half and half, right? You'd say the most likely outcome is, right, that 500 heads and 500 tails. Okay, and that is true. That is the most likely outcome. If you were to take this probability formula, right, and try to solve, actually no, not this formula. No, never mind. You'd have to write this in terms of instead of having p1/2, it'd be like px or something like that, where you have like x heads or something, and then you'd have to put that. But you could write this probability in terms of having any number of heads out of your total coin flip, and then take the derivative of that with respect to that variable and set equal to 0, and you find that the most probable outcome, right? The outcome with the highest probability is always half heads, half tails. Okay, that is always going to have the highest possibility of occurring, even though it occurring is very unlikely, right? Right. If you were to go to Vegas and bet on flipping a coin 1,000 times, what the outcome is going to be, right? Be a very bad bet to place for any outcome, because the likelihood of any specific outcome is very, very small, right? If you had to put a bet on what's the most likely outcome, right, then that'd be a little bit better in your odds to say, well, most likely it'll be 500 and 500, right? Yeah, but I mean, but again, even that wouldn't be great, because even though 500 heads, right, 500 tails is most likely, right? Again, is more likely than other outcomes, but not like necessarily significantly more likely than say 501 heads and 499 tails or something like that, right? So, right, not say a bimodal distribution or something like that, where you have like one outcome that's very likely and the rest are essentially 0, right? Yeah. But yeah. So questions about this, right? So I mean, we're going to be talking about shoot, not modified. Yeah. Yeah. So any questions kind of about this stuff, this idea of probabilities, statistics, likely outcomes versus most probable, the probability of specific outcome, and things like that? I mean, I mean, in examples like doing, we're not going to use either of those two for anything. So I mean, I mentioned on Friday that out of this material, there's there's not too much that potentially could be covered on an exam and things like that. This stuff today is not going to pop up. I'm not gonna have an exam question on coin flips and things like that. Yeah. Stuff that we'll talk about on Wednesday on Boltzmann statistics, that is a possibility of appearing on an exam. And so that we'll be spending more time on that, doing some examples with that and things like that. That's specifically for Boltzmann statistics. And that is going to be relevant because we'll also be talking about Boltzmann statistics when we talk about quantum mechanics and things like that later. So yeah, and it's related with spectroscopy and a bunch of other things. So Boltzmann statistics will pop up a lot next semester as well. And so that's why that one I want to make sure people at least have an understanding of it and study it and do it. But things like this, flipping coins and stuff, no, you don't need to know any combinatorics or anything else like that. Okay. Other questions? So just some other kind of statistics type things, probabilities and such. Is anyone familiar with I forget what the question's called itself, but essentially like a game show question for probabilities. You get three. Yeah, that one. Oh, okay. Yeah. Okay. Yeah, see, that's the funny thing. I actually never took a statistics course in my life. I never took it in high school and never took one in college. Taken all sorts of other math, linear algebra, complex analysis, group theory, all sorts of other types of math, but never statistics. Never taken a statistics course in my life. Yeah. Huh? No, well, my so for me, this is like so I went to University of California, Santa Barbara. There they have like here we have a College of Engineering or no College of what are the colleges here? The College of Science, I feel it's called now. So I'm here in Texas State. Science and Engineering. Thank you. That's like I might blanking on it, right? College of Science and Engineering, College of Humanities, or like a bunch of different colleges, right? Each college has their own kind of majors that are in those colleges, right? Well, at the university I went to, they had these same type of colleges, but there's basically like there's three colleges, and that was it. There was a College of Letters and Science. I don't even know what its name was for. That was basically like every major essentially on campus, except there was the College of Engineering. That was all the engineering majors. And then College of Creative Studies is what it's called. The College of Letters and Science had every major but engineering. College of Creative Studies had only a couple of majors, but they were the exact same as like College of Letters and Science. So you could get a chemistry major in the College of Letters and Science or a College of Creative Studies. Okay. In this College of Creative Studies, you had more freedom for what your courses were. And that, so I was in this College of Creative Studies, so I had a lot more freedom to kind of pick my classes. So I took a lot of physics classes, took particle physics and things like that, a lot of math classes, and stuff. And actually only took one. So it's also on a quarter system or trimester. I don't know why they call it quarters when it's trimester, but whatever, right? But a trimester system, and I only took one out of the three organic lab classes because I was weasel my way out of the other two. But so, yeah. Well, the third lab used all of the same like stuff the first two labs. All the techniques that you needed to know for the third lab, you had to learn and do in the first two. I was like, well, if I can just take the third, I'm learning everything I need to know anyway, so why don't I do that, right? That my advisor didn't think I would be able to sign up for that lab because of prerequisites, but somehow I was, so I signed up and took it, and he's like, well, shoot, all right, I guess I told you it's okay. But I did have to not necessarily tell the truth as to whether or not I had taken the other two labs to my TA because, yeah, I just said, oh, I took it a long time ago. I took it over a year ago. The other two, I've forgotten a lot about them. Yeah. No, because there's someone who said that they'd skipped the lab, and the TA then kicked them out of the class.
Oh,
So I was like, yeah, so I kept my mouth shut, and that's fine. Anyway, so yeah, that's why I didn't have to take this long story told in a long way. Not really long story short, but yeah. So trip down memory lane. What else here? So that's so I guess I'll say in terms of stuff today, I just wanted to kind of talk about again statistics and introduce this idea of statistics. Next time we'll spend again the day talking about Boltzmann distribution, the Boltzmann statistics, okay, and going over this Boltzmann distribution function, which is given here, right? And we'll talk a lot more about that, talk about different examples, do some questions using it, and things of that nature. Okay. Oh, blink question. All right, got to fill that in. But yeah, but I don't really want to start it today and then have to finish it on Wednesday, so we aren't gonna go over that today. But again, want to introduce these ideas of statistics, probabilities, and things like that, refresh our memories about it, so we can kind of talk more about it on Wednesday, but in specific examples of things where you have a bunch of energy levels and a distribution of molecules across those energies and total energy, total number of molecules, and things like that. And what is the probability of having an occupation within a given energy level and things like that, and what's your average energy, and answering those types of statistical questions based off of this premise. Okay. Yeah, so we'll just end here today. A little bit shorter day today. That's fine. But I'm happy to answer any questions people have about whatever. But otherwise, you're welcome to leave.
Yeah, so if you start there, exactly. Right. You start with ingredients.
Right.
And then they all switch.
You always switch.
Yeah, I don't even know what the 66 is. Yeah.
Conditional probability.
Yeah.
Yeah. Which,
Yeah, interesting. We did that in my. We did that in my college. I was like, okay, cool. Yeah, like